Hello again. Welcome to another lesson in Algebra 1. Today we're covering section 12.5, multiply and divide rational expressions. So once again, this lesson was covered in class, but in case you were absent or just want to review, this is a place where you can check out the video again. All right, so factor each polynomial is our warm-up, so just some review. We'll look at the first one. We're looking for two things that multiply to 12 and add to -7. So that's going to be -3 and -4. Because the leading coefficient is 1, we can go right to our factored form of m minus 3 and m minus 4. All right, and number 2 is a binomial, and we can just look for what's the same in both first. So this will be 2m is the common factor, common monomial factor, and it leaves behind m plus 2. So this is factored form. The binomial that's left cannot be factored anymore. All right, number 3. This is a binomial, but there is no common factor in them. However, it is a difference of squares. So this is one of our special ones. This factors into 2x minus 9 and 2x plus 9. Remember, the square root of this is 2x and the square root of this is 9. That's why it's called a difference of perfect squares. Okay. And then number 5, this is much easier if you factor out the common monomial of 5 first, at least behind n squared. Minus 3n plus 2. So we factored out that monomial of 5. And what's left is still a trinomial, and this one can be factored. We're thinking of two things that multiply to 2 and add to -3, which are -1 and -2. So this will factor into n minus 1 and n minus 2. All right, so our only new stuff today is very similar to last lesson. We're just simplifying fractions, but in this case, we have to do some multiplying or dividing first. All right, so when you multiply fractions, you multiply the tops, you multiply the bottoms, and then you reduce. Now there's some shortcuts to it, but we're going to go with the long way to begin with. 2 times 15 is 30. X cubed times x cubed is x to the 6. You got to go back and remember your exponent rules. That's the product rule. When the bases are the same, you may add the exponents. On the bottom, we do 5 times 8 for 40. And x to the first power times x to the 6th power is x to the 6th power, 1 plus 5. All right, so with this, our exponent rules said cancel the numbers in front. Those cancel to 3/4. And then cancel the x's. And since we have the same number of x's, we can cancel them all out. So our answer is 3/4. However, we could do some fraction skills here with multiplication. We are allowed to cross cancel. So if I started this problem over again, I could say something like this. The 2 and the 8 would cancel to 1 and 4. The 15 and the 5 would cancel to 3 and 1. And you can see where the 1 times 3 makes 3 and 1 times 4 makes 4, so where the 3/4 comes from. And then we could cancel out some of our x's. So we could say, oh, there's a 1x here. That'll cancel and make x squared. And then there's 2 here with 3 here, so those will cancel with the 5 on the bottom. So we could do cross canceling and up and down canceling. And when we're left, all the x's canceled out, and all we were left with was a 3/4. Okay, so I'm going to do that over here. Okay, let's see. This x cubed could cancel this x cubed. This, I'm sorry, z. This z can cancel one of these two z's. So I know there's going to be a z up top. And then for numbers, we have a 7 up top and a 14 on the bottom. So we can make that one turn into a 2 and that one turn into a 1. So we've used up everything on top. We just have one z. And on the bottom, we have 4 times 2 for 8. So z over 8. All right. When we have trinomials and binomials, it all works the same. We're just going to try to factor everything so we can see what could cancel out. Okay. So our top left here would factor into n minus 1 and, I'm sorry, oh, that's good, and n plus 2. And the bottom, because these are the two things that multiply to -2 and add to 1, the bottom's going to factor into n and n plus 2. I can see something that could cancel already. And then over here, we can take out a 2n, and that leaves behind n plus 2. And on the bottom here, we can take out a 5. And then what's left behind, we've already done this. So I'm going to cheat. It's going to be n minus 1 and n minus 2. This was the same as our warm-up problem factoring. Okay. All right, now we look for things that could be canceled out. Okay, because we can cross cancel here. So I can cancel this n minus 1 on the top left with the n minus 1 on the bottom right. Remember, any top can be canceled with any bottom in fractions. So this n plus 2 could cancel with this one. That's a top and a bottom. This n could cancel with this single n here, the monomial n. And then when I'm done here, I have nothing else that can cancel, so I multiply it back together. This will be 2n plus 4 on the top and 5n minus 10 on the bottom. Okay, so that's our reduced fraction. Number 4, we've got to factor the bottom left here, so this will be 2m squared over top of two things that multiply to 12 and add to negative 7 are negative 3 and negative 4. So m minus 3, m minus 4, and then on the top is an m minus 4, and on the bottom was a 1. Okay, so we look for things that could be canceled. And in this case, m minus 4 on the bottom and this m minus 4 on the top can be canceled together. There's nothing to cancel with the 2 and nothing to cancel with the m squared and nothing to cancel with the m minus 3. So we're left with 2m squared over m minus 3. Okay. All right, that's reduced as it can be. Let's flip it over and see a couple more. On the back side, we have division. So remember, division is the same as multiplying by the reciprocal. So this is going to be m squared minus 4, 2m squared plus 4m times 4m plus 44 over top of 6m minus 3m squared. All right, so I just changed it to a multiplication problem. Remember, dividing fractions the same as multiplying by the reciprocal. And now I'll factor. So I have m minus 2, m plus 2 on the top left. That's a difference of squares. On the bottom, I take out the common monomial, which is 2m, and it leaves behind m plus 2. On the top, I could take out the common monomial, which is 4, and it leaves behind m plus 11. And on the bottom, I'll take out a common monomial, but I'm going to actually take out a negative 3m, so I can flip it around. And that will leave behind m minus 2. Now notice if I multiply this back in, it's negative 3 times m, which makes negative 3m squared, and negative 3 times negative 2, which makes positive 6m. Okay, and I wanted to flip it around because I knew all my other factors had m as the first term. All right, so this m minus 2 and this m minus 2 will cancel. This m plus 2 and this m plus 2 will cancel. This 2 right here can cancel with the 4 to make it a 2. And then I have nothing left on the bottom that can cancel with the top. So my top is going to be 2m plus 22. And my bottom is going to be m times negative 3m, which makes negative 3m squared. So this is my reduced form. All right, last one. Number 6. I'm going to go ahead and factor this while I'm thinking about it. So this is x minus 3, x minus 3. It's a perfect square trinomial over 12x. It's going to be times by 1 over x minus 3. So one of these x minus 3s will cancel with the one on the bottom. Nothing else can cancel, so we keep x minus 3 on top, and the bottom has 12x. All right, that concludes our last lesson. Your classwork was page 806, 3 through 21 multiples of 3, and then 29 and 30.